Okay, so this is the very last video, very last lesson of Algebra 1 honors this year. We're going back to 10, chapter 10, 10.1, the Pythagorean Theorem. This is something that you would have learned in pre-algebra, but because you were skipped through pre-algebra, so you skipped an entire grade, you didn't get it there. So this is the last thing you really need to know before you go on to geometry. Pythagorean Theorem, it's a formula. A squared plus B squared equals C squared. Not very hard, but we need to review a couple of things before we start to use it and really talk about it. So let's review the reciprocal properties, specifically squares. Okay, how do we get this x right here alone? We have x squared. We need to do something to it that cancels out that square. So if you remember from maybe solving quadratic equations by the roots method, in order to get rid of a square, we would be able to take the square root of it. So a square root cancels a square because this particular symbol has a little index here, technically, of 2. So the square root cancels the square, and you're left with x. And of course, it's the same thing in reverse. If you have the square root of x, how do you get that by itself? Well, if you square it, the square cancels the square root, and you're left with x. That's our first thing we have to remember. Now let's look at the next one. Maybe not. Maybe you don't remember all this, but triangle parts. Okay, a right triangle, and this is the most important. All our problems we're dealing with are right triangles. That means it has a 90-degree angle. And just for knowledge, which you're going to have to use all the time in geometry, you have to remember that all 3 angles in a triangle should add up to 180 degrees. Okay, now we have different bits and pieces. So here's an example of what a 90-degree triangle here would look like. The little square means it's 90 degrees. The other 2 angles are 70 and 20. You add them all up, you get 180. Notice these are the marks that they use for angles. They'll do like a little scribed circle there. And then we have sides. There's a side A, a side B, and a side C. Side C is the hypotenuse. It is very, very important to remember this, that side C is always the hypotenuse. Look at our formula. Up here at the top, the Pythagorean Theorem. C sits in a certain spot. It's all by itself after the equal sign. A and B are together. Well, what are A and B? A and B are the legs. They call these the legs of your triangle. They're the 2 shorter pieces. So the hypotenuse is always the longest side, and it's always opposite. It's opposite that right angle for you. Okay, hypotenuse, longest side, it's always opposite. Why do we need to know this, Mr. C, you might ask? Well, they're going to give you something that may say, label the triangle. Or they'll give you A, B, and C, and you know how you have to plug it in or substitute it into that Pythagorean theorem. They also may call it this, a Pythagorean triple, which means they want to know, are these the 2 legs in the hypotenuse of the particular triangle you're dealing with? So you have to remember that, okay, first we need to make sure we know where C is. C is always opposite the 90-degree angle, so C is 5. And A and B are the legs, so we have a 3 and a 4. Notice the longest side is opposite the 90-degree angle. This is C. Now, is it a Pythagorean triple? Well, I don't know that. We'd have to plug it into the formula to find out. So if you remember, it's what? A squared plus B squared equals C squared. So if the legs are A and B, so you have 3 squared plus 4 squared equals 5 squared. And you simplify. Well, this is 25, and this is 9 plus 16. And yeah, sure, 25 equals 25. So this is a Pythagorean triple, or this is a true 90-degree angled triangle there for you, a right triangle. So that's what a Pythagorean triple is. And then basically you need to know that a square can undo a square root, and a square root can undo a square. And then you're able to do these. These are not that hard. You'll find, because we've done all that studying in all of chapter 12 and the square roots and the roots and solving by root method in chapter 9, this isn't as hard as it looks. The hardest part is making sure that you put C where it should be. Okay, let's look at some of the examples you're going to see in your homework. It says, use the Pythagorean theorem to find the unknown side of the triangle. Okay, so we have one side here, and we have one side here. And we notice that this is a right angle. So what's always opposite our right angle? C, the hypotenuse. All right, so we have 7 squared plus 24 squared equals C squared. Okay, remember this all came from our Pythagorean theorem. A squared plus B squared equals C squared. We know that the legs were 7 and 24, so we substituted. I'll wrap them in parentheses so that we can be absolutely clear. We substituted the legs in, and now it's just simplifying. Well, this is 49. You might need a calculator for this because I don't know what 24 squared off the top of my head is. Which comes to 576. And all of that equals C squared. Oops. Clean that up. All right, so now in your calculator, 576 plus 49 is 625. So 625 equals C squared. Now this is why we had to remember those reciprocal rules. C, we're solving for C. C is not by itself. So how do we get rid of this square? We take the square root of it. And then we take the square root of it. Now I know that you guys are probably wanting to do this. Plus or minus. But this is a real world problem. Would we ever have the length of something being a negative number? No. So because it's a real world problem or real world application, we won't have a negative length. Okay, so we only need the positive result. And if you take the square root of 625, you should get 25. So this cancels this. You're left with, write this. So C equals 25. And there you go. Here's another Pythagorean triple that you have. 7, 24, and 25. 7 squared plus 24 squared equals 25 squared. All right, let's look at the next one. The next one is very different, not so much different, but they're asking us to solve for a different piece. Okay, it says find the length of the third side of the right triangle. Give the exact answer and an approximation to 3 decimal places if needed. Okay, so we need to set this up. We have a squared plus b squared equals c squared. Well, notice that what's opposite the hypotenuse, there's opposite that 90-degree angle is the hypotenuse. So we have a 24 squared. We'll say 24 is A, plus B squared, because we don't know what B is, equals 25 squared. All right, now we just have to go ahead and solve some stuff. If you notice, this problem here looks an awful lot like the problem we just had above it. Maybe they're just trying to teach us something here. We'll see. So 24 squared, again, 24 squared is 576. And we have a plus b squared. And 25 squared is 625. Now, if you look at this, we're trying to solve for b, so we have multiple steps we have to do. We have to subtract 576 from both sides. And now we're going to have a b squared equals 5 minus 576, 49. Notice b is still not by itself, so you have to take the square root. Take the square root. So now you have b equals 7, because the square root of 49 is 7. And we know that that's right because we just solved one right above it that was asking us to solve for a different piece. But they're proving it to you that these work. Okay, so this is 7. The next one, number 3, is just like the first problem we did, so you guys can do that one. This one here, number 4, it says, so a jogger, this is sometimes you have to like maybe draw a picture. Okay, it says a jogger is going east, so he's starting at one point. All right, jogger's going east, that's west. So I get my directions right. So you have a jogger here. That jogger is going east 1.5 kilometers. 1.5. Then he does what? The jogger turns south for 1.7. And they want to know how far south did he go from his like original point. So you have here is a right angle because he was going east. Then he turns south. That's a right angle. And so they want to know what is this like dotted line through here. Okay, so we are trying to find the hypotenuse. So you have 1.5 squared plus 1.7 squared equals c squared. And guys, the rest of this, it's all calculator. Okay, so you're going to put 1.5 and you're going to square it. You get a 2.25. And then you have 1.7 and you're going to square it and you get 2.89. Then you have to add your two decimals together, so 2.89 plus 2.25. Use your calculator. It's perfectly fine. That gets you 5.14 equals c squared. Remember, take the square root, take the square root. We got to be careful here. Did it say what we needed to round our answer to? No, it doesn't. So let's see what happens. 5.14, and then we take the square root of that. Gives us 2.26. So since everything in this particular problem is only one decimal point, we'll round that. So 2.3. Because this gave us 2.26. The 6 says to round that up to a 3. And that's your approximation. Okay, here we go. All we have to do here, guys, is look. Determine whether the given numbers are the lengths of a right triangle. Okay, then it says, do the given numbers represent the sides of the right triangle? Yes or no? So you have to set up this equation and see, is it true? Notice, what is the longest side? The longest side is 121. So you're going to do 28 squared plus 122 squared equals 125 squared. So you calculate this, you add these two together, calculate this, do these two added up, total this. That's it. And if it does, then you click yes. If it doesn't, you click no. This one here is exactly the same thing again, but now they're calling it something. They're calling it that Pythagorean triple. So again, your longest point is this. You need to identify it, C, and then you'd have a B, and you'd have an A. Plug it into your Pythagorean theorem. Is it true? If it's true, then yes, it's a triple. And here's the final one, is a word problem. Yes, I'm going to end the year with you guys with a word problem. This is the Pyramid of Giza, I believe. So here it's a truncated pyramid. So they definitely know what the base is on this triangle, because it's easy to walk from here to here. They know what this particular measurement is here. Let me get my notes, because the other one is hard to see. And the height, this height here is 623 feet. So this is 623 feet. Okay, so we know the height of that, because the wall, that flat wall of that pyramid is a triangle. We know that from if the entire length of this triangle here is this, they've cut it in half and they made a right angle. So we want to know, well, what is this hypotenuse? This is C. This would be your A. And this would be your B. And you can set up your equation and solve. 377 squared plus 625 squared equals C squared. And then you go from there. Do the math with a calculator, do the math with a calculator, add them together. Take the square root of both sides, and you'll have how long that C length is. All right, guys, get busy. 7 problems. I have to say, we have learned an awful lot this year. I told you from day one you were going to learn more than you probably ever have. It's been a lot, and it's been a pleasure. One of the best. Have a great one. Let me know when you're finished with stuff this week. If you finish up early, you're done. So have a great week, guys.